Thanks everyone for coming. Those who don't know, I'm Katie. I'm the intern team lead. I've been guiding the interns over the last 2 months, and I hope you will all be as impressed as I am about what they've achieved in such a short space of time. So, without any further ado, I'm going to hand over to the interns so they can explain what they've been doing.
So, nice. Hello, everybody. Hi in the office. But yeah, so thank you for coming today. Really excited to tell you all the stuff we've been doing as part of this year's HDI program and the project that we've called Data Capture. So in the presentation today, we'll first introduce the problem that inspired this project and the solution that we've come up with. We'll take you through all of the technology that we're using, and as part of that, we've developed an app. So we'll give you a demonstration of how that works, and also talk to you about sort of like why it works the way it does. And we'll go through some marketing, so the costing and the branding that we've used. And at the end, we'll show you some ideas that we have about the future directions for what we've already got. And of course, there'll be time at the end for any questions or thoughts you may have. So firstly, just to introduce the problem. So in 2020, the Cambridge Review was published, which highlighted concerns regarding medical implants. And it really highlighted the absence of a national theatre data set that's able to identify patients who've been given a particular medical device. And having spoken to doctors at the start of the internship, we also identified issues with how the information is recorded. So a lot of hospitals are still using pen and paper systems, and this is really time consuming when you consider all of the information you have to note down. And so this means often this recording is done at the end of surgery when important factors like the quality of a batch aren't considered until after it's been implanted. And this can sometimes lead to really dangerous side effects or consequences. So for example, the PIP breast implant scandal, where 47,000 women in the UK received a breast implant made by a French manufacturing company who cut corners and used a really cheap industrial silicone as opposed to a medical silicone. And this was really dangerous and led to an increase in number of ruptures from these breast implants. In the UK, however, it was really hard to identify all of the women who had received this particular implant from this manufacturer because there wasn't a national theatre data set. And that means today still women are left, feeling anxious and not knowing if they have that particular breast implant. So this poses really important questions, such as how do we ensure there is a way to record all of this information and that it's efficient enough to recall patients if that's required, if an implant is noted as faulty in the future. And how do we implement this system across the UK, across all hospitals, regardless of their level of digitization? So this led to the aim of our project, which was to come up with a way to digitize the way data is recorded in operating theatres. So as part of this, we called our solution Data Capture, and this encompasses two main methods of data collection. So the first method is using an app. So we've developed an app that will record information about the patient, the implant, and the location. So the app will scan patient wristbands, which have a code on them, and this will detail their name, their NHS number, their date of birth, and so on. There will also be codes on the implants, detailing the manufacturer, the batch number, the expiry date, and finally a big QR code will be on the wall of the surgical theatre, which will be scanned. And so this means there's sufficient amount of evidence, information that you'd need if you needed to recall that patient in the future. So alongside this, we're also collecting information from anaesthetic machines like the one you can see here. And currently the stats, so the heart rate and the oxygen levels from this machine are anonymized. And so it means that they can't actually be used. However, what we're doing is taking that information and linking it to the patient by storing it in the same place in the cloud. And so that makes this data clinically valuable and usable. So that's just a short summary of what we've come up with. But all the way at the start of the internship, we wanted to make sure the solution we came up with met the demands of our customers. And we did this by coming up with a value proposition board, which Louise will talk through with you now.
Yep, so thank you, Jess. As you can see, this is our value proposition board, which was really useful in the first week for making sure that there was a fit between all of the cool ideas that we were having and different technology that we were trying, and making sure that it was actually useful for people who needed it. So if you're not familiar with what this actually is, this circle represents the market. So customers and things that they would want in a product that we could make, and also things in the current system that cause pains. And then the square represents things that we as HDI can do to hopefully ease some of those. So when you look at the customer jobs on the far right, then you can see some of the things that we were hopefully planning to ease and find a way to automate. So manually typing up data and changing it into different formats so it can be sent on. We thought that could be something we could help with. An anaesthetist having to write down information from the machine by hand. We thought that would be good to ease as well. And theatre staff having to check important information about the implant, such as the expiry date by eye. We thought it would be good to have a check on that as well. So everything on this canvas, we managed to split into 4 key areas of things to consider while designing. So the first one is time. It doesn't really matter if we create something that's really cool and works really well, but it takes ages, because it's just not going to fit into the current process in operating theatres. So having to type up all of the data and send that on properly is a thing that can damage job satisfaction in the NHS at the minute, because people aren't trained to work admin roles, you know, and having to just do all that by hand can be frustrating at times. So that was why we had to keep time at the forefront. And then secondly, safety. Whatever our product is, it had to increase the safety of the current systems. And so by reducing mistakes, so reducing incorrect implantations, that was something that we could do as well. And whenever there is scandals, like Jazz mentioned with the PIP implants, that does damage the trust in the NHS. So we want to try and reduce that if possible. And then the third one is cost. Again, if we have a really complicated solution that we think works well, but it's expensive, no hospital's actually going to use it. So we had to make sure to try and keep this in mind. And so that also helped us with other applications of the eventual app that we came up with. So instead of just having it to scan things in the operating theatre itself, we've used it for stock checking, for example, as another way of saving money. And that is a benefit that our product has compared to things like Scan for Safety in the past, which was quite expensive to implement. And then finally, it has to be easy. So when designing the app, this was definitely kept in mind, and having to make sure that staff wouldn't have to, for example, go through a course before being able to use it. So the implementation and getting used to using it would be easy. Yeah, so that was really useful in helping kind of understand what the best routes for us to take was, because in the first week, it was quite difficult to understand, well, it seems like such a big problem, how are we going to sort it out? But once we had this in mind, we were able to experiment with technology, and Alex is going to chat about that.
Thanks, Louise. So yeah, I'm just going to give a short summary of the technology we've used, starting with the patient. So we're in the operating theatre. We've got the patient hooked up to a nice machine through various tubes, wires and plugs, so on. So this machine will show all of their vital stats like heart rate, blood pressure, oxygen saturation, and currently that's just written down by somebody who reads it off the screen. But what we've come up with is a solution which hopefully will be much easier. So to start with, we've got a Raspberry Pi, which is actually a little computer board. It's not a real Pi, and that plugs into the back of the machine. And we've got one here actually. If you can see me, it looks like this. Anyway, yeah. So this Raspberry Pi can read all this data. We found some code to read the binary data in this machine and put it into a human readable format. The Pis also have Bluetooth enabled. So that means they can communicate to a device. So we've gone for personal devices. So we've made an app that can be downloaded on iOS or on Android, just to reduce cost and to make this accessible to all hospitals, irrelevant of their kind of tech levels. So the Pi can send over whatever it wants, basically, but the way we've decided to make the connection secure is by allowing all the Pis in the hospital. So you might have more than one operating theatre. All the machines will connect to the phone. They'll send over their vital stats, and then you can select the one which your machine matches to. So there's a really secure connection, and you know you've connected to the correct machine. So then we select, and it disconnects from all the other Pis in the hospital. The next thing would be for the app to start scanning. So we've got QR codes on the wall, which would encode the location of the operation. And we've got the patient's wristband, which encodes the patient data, date of birth, NHS number, name. That can all be sent to the cloud by the phone. And that can also be linked to the data coming out of the machine, which is sent to the cloud via the Raspberry Pi. And the way these two things are linked is via a session ID, which the Pi can send to the phone. So all the data from one operation will be tagged with a session ID, and we can just go back and say, oh, this is the same session ID. There was this patient, there was this data at this time. Sorted, hopefully. Yeah, so now I'm going to hand over to Nu, who's going to talk to you about getting data out of this machine.
Cheers. Yeah, so at the beginning of the internship, 2 months ago, we were presented with the latest addition to the HDI office, the 7th intern, which is this machine, right? And you look at it and it's this sort of sci-fi thing, especially if you're not an anaesthetist. Otherwise, it's pretty friendly, I'm sure. But we needed to get some data out of it. We needed to communicate to it somehow. And there's not a lot going on communication-wise from the front, but the back of it looks like that. And you can see there, that's where we're communicating to it. We spent about 3 days trying to send binary messages in through a variety of methods. And we were just shouting into the void. We were getting nothing back, not even, you're not saying the right thing. So we were a bit stumped. We did a lot of Googling, a lot of burying our heads in manuals, which are quite dull. Yeah. But we came across a bit of code that someone had written in C# that actually kind of looks like some of the code they've got in the manuals that sends something in and starts printing things out. The only problem was we were running that code and getting nothing. So we didn't really know if that code was working or if our code was working. And then, after lots of head scratching, we even tried to connect to it through the network at one point, but that kind of went nowhere. Tim decided that we needed a null modem. We bought the cable, we plugged it in, and suddenly we got data out of the machine. I'm seeing Ari squirm over here. Apparently so 3 days later, we had something out of the machine. And so then we recorded that data and we kind of created a bit of code so we could just relay that back to ourselves so that we could work and develop our system without needing to connect to this thing. And kind of moving forward, we want to rewrite that guy's code that we're using at the moment to kind of integrate it with our system. And now I'm handing over to Laith. Tom to talk about the Bluetooth.
Thank you. Okay, so as Alex said earlier, we need to send certain bits of data from the Raspberry Pi to the phone. We need to send the heart rate and oxygen so that they can see the vitals on their phone, make sure they're connected to the right machine, and the session ID so they can both communicate to the same reference in the cloud. So we send these messages using Bluetooth. We looked at a number of options. We started off with radio frequency communication pairing, which is the same technology as you use to pair your smartphone with a speaker or something. The issue with this is that the number of devices your phone can connect to, and even more limiting, the number of devices the slave, which is the Pi in this case, can connect to, is not enough. So you wouldn't be able to look at multiple machines at once and decide which to choose. It then went on to trying to emulate Bluetooth low energy beacons. So these are normally little devices that periodically send out a broadcast. and a small payload of data. We got this to work on a Raspberry Pi, so it sends the same packets of data. The issue with this attempt was that you couldn't send enough data in each packet to store all the data that needed to be sent to the phone. So then we tried modifying these protocols to make the payloads a bit longer so we could fit everything in, but that wasn't successful either because it was very unreliable. So we finally got on to what we are using at the moment, which is Bluetooth GATT. GATT stands for Generic Attribute Profile, and it makes data available in this hierarchy. So at the top level, you've got the service, and this differentiates it from entirely other applications. And then under this, you've got characteristics. We've got the 3 that we're sending to the phone. And so these are kind of what the phone asks for. It says, okay, I want to know about the session ID. And then under these characteristics, you've got values. Now a characteristic can have multiple values. In this case, it just has 1 each. And the values are kind of the lowest level variables, so strings and integers. And the characteristics, they're slightly different types. So some of them are notify characteristics. So the Pi periodically sends it out to the phone. And then the session ID, the phone only needs to know that once at the start of the operation. So that's a read characteristic. The phone asks for it, the Pi sends it back. So now we've got data going to the phone. Both the Pi and the phone also need to send up data to the cloud to store everything long term. So I'm going to talk about the Pi side of the cloud now. So the Raspberry Pi sends up MQTT messages. So MQTT is a protocol which is a bit like HTTP, which is used to send web page content. Except this is designed specifically to be very lightweight and use little bandwidth, which is perfect for its application when we're continuously sending up data from a very small computer. In this setup, this is kind of an Internet of Things setup. So the Raspberry Pi here is a thing, and then that means we're using all the AWS IoT services. So AWS is Amazon Web Services. That's just the cloud provider we're using. So going back to the diagram, all the blue icons are part of Amazon Web Services. The message broker simply subscribes to messages from all the Raspberry Pis in any hospital. It then pipes this into a rule, which is a bit of logic that basically says, okay, I'm going to need to split this data into multiple columns and put them into the database, which is just a table where we store all the data. And we'll show you what that looks like later in the demonstration. So setting up the cloud infrastructure is actually quite difficult, takes a while, and you can go wrong at many points. So because we're going to be setting, well, in production, you'd go to a hospital and want to set it up with a number of Raspberry Pis for each operating theatre quite quickly and easily. We need a reliable way to do this. And so instead of manually going onto AWS and selecting exactly what services you want, we can use Terraform, which is a tool that takes code, which is a description of the services you want, and it applies them to the cloud. It talks to AWS and it says, I want this, this, and this, and AWS makes it. So it's very quick and not very error prone. It also makes making slight tweaks to your setup very easy. So if a hospital wanted to add a new operating theatre, for example, all you'd have to do is edit the code a bit, add a new name to an array, reapply the changes, and then that's pretty much it. Your Pi is going to work. You've got a new operating theatre. One cloud service we didn't get to work, but we have set up a repository for this to be easily integrated in the future, is AWS Greengrass. This is basically a service that makes management of all the Raspberry Pis, all the things in all the hospitals, very easy to manage. So for example, if we want to update the code, maybe it needs to send different messages to the phone, we can do that through Greengrass, and it applies all the updates to all the devices we want at once, rather than having to go through each of them, and that would take a long time. Another benefit of Greengrass is that it kind of makes the cloud work on a local scale, so that if the hospital's internet connection to AWS is severed, all the data being sent from the Pi to the cloud is stored temporarily until that connection resumes. So basically, you're not going to lose any precious data. So now I'm going to hand back to Nu, who's going to talk about the other side of the cloud relating to the phone, to the app.
Yeah, so a large part of the project is being able to connect the data that we're collecting out of here with actual patients and patient records. And in addition, because we can, we're trying to log the implants going into people. So we needed to collect the data coming out of the phone. And for this, we're using another Amazon Web Service product, which is AWS Amplify. So we kind of thought about, constructing our own backend, having a DynamoDB database as well, but kind of with our own API. But from looking around, Amplify seemed to be the way to do it. So in just a few commands, you kind of add this API. By the way, I should mention an API is, well, in a simplest form, is essentially the way that we can communicate with a database to update and create records. So with just one or two lines of code, you end up with a GraphQL API, which is just how we update those records in our DynamoDB database. And so to authenticate these requests, we're currently using Amazon Cognito. So at the moment, we're using unauthenticated requests, so anyone can submit data, but in the future, that's really easy to scale it up so that we can authenticate users. So just hospital personnel are allowed to use the app and submit records. Another feature of how we're sending data to the cloud is through consistent updating. So every time you scan something, it goes up to the cloud. We're not collecting all the data locally and then sending it at the click of a button. A benefit of this is that if my phone died during an operation, then someone else can come in, connect to the Pi, pick up that session ID and collect the records from the cloud and then complete that record. So we end up with better data completeness and just kind of better collection overall. And now I'm handing over to Leith to talk about connected to machine.
So we've connected the Pi to the cloud, we've connected the phone to the cloud. Now we want to make sure that we're connecting the phone to the correct Pi. And at the moment, we're doing that by asking the user to choose their machine from a list of machines that will be displayed in the app. And for each machine, you'll see the heart rate, the oxygen, so you can match up with the machine in front of you, which Pi you want to connect to. And that list will also be ordered by proximity of the machine. So all the available machines will be in the list ordered by where they are in the hospital. So how do we generate the list? We connect to all the machines that we can see in the hospital. And then we order those machines by proximity. And we do this by taking a recording of the signal intensity of the Bluetooth signal that comes from the machine. Now, the problem with this intensity measurement is it fluctuates quite a bit. It's quite random. So we need to take averages of those signals. So we take an average. So the longer the time period we take the average over, the more accurate the reading will be. But then it takes longer for the distance to update on the phone or for the intensity measurement to update. So if you're moving around, you've still got measurements from when you were over there. So we need to balance it with how accurate we want it to be and also how quickly we want the list to update the order if you're walking around the hospital. So we've gone for something on the order of 5 to 10 seconds, which is how often the list will refresh. And then in order for it to be easy for the user to use, we convert that intensity measurement to a distance. This is it's not a particularly accurate calculation because you don't know what obstacles are in the way that people might walk in front, etc. So it's quite a rough idea of how far away it is. So we put it into bins of say 0 to 5 meters, 5 to 10 meters, but it just gives the user an idea of the scale. So you could have two machines, one's miles away, one's next to you, but you can see probably it's the one that's next to you. So you might ask, why don't we just put a QR code on the machine and scan that to connect to the machine instead of doing all this complicated listing? and we did kind of think about that. Yeah, and we thought, you know, it might be quite small on the machine. You might be leaning over the patient trying to scan it. It's an extra thing to scan, which could be difficult. The QR code might fall off, and then you've got no way of connecting to the machine. And also, it would have been less fun for us to just. So we generated this list.
But more importantly, Leif, as well, the QR code and the pi might get separated, as it were, or changed as well. So you might end up being very certain that you're connecting to the right pi when actually you're connecting to a different pi.
Yeah, so if the pi's on the back of the machine switched, you'd then have the wrong QR code. Yeah. So also in the future, we might like to have the machine automatically know where it is, and maybe also the phone knows automatically. So if both the machine and the phone know they're in the same operating theatre, they can just connect without the user having to select from this list. So one way we looked at doing this was to use Bluetooth beacons, which Tom has already briefly mentioned. They're like small USB devices that you can just plug into the wall, and they emit a Bluetooth signal like 10 times a second or something. And you can read the intensity of those signals, and also a little unique identifier for each beacon, so you know which beacon the signal came from. So the idea was to put one beacon in each operating theatre and have that identifier linked to the operating theatre. And then the machine and the phone can read the intensity of the signals that are coming from those beacons and see which it's closest to, or just kind of a map of which operating theatres are around and how far away they are. So initially, we're just going to send that beacon data up to the cloud so we can test the algorithms that we've got, because we don't know how accurate that might be. So for the moment, we're just getting the user to select and just sending the data up. But Alex and I worked on an algorithm for locating the pi indoors using Bluetooth beacons at the start of the internship, which I'll just briefly go through now. So the idea was to try and work out which beacon is closest to the machine. So since the machine is stationary, the machine can calculate averages of the signal intensity over much longer periods of time without having to worry about refreshing the list. So we can calculate, so what we do is calculate lots of groups of averages of, say, 50 samples that we record. And then we can analyze these averages, how these averages are distributed, because they all follow a normal distribution, which then allows us to do statistical tests on the average data. So here we've got two plots just to illustrate. So on the x-axis is the signal intensity. Intensities further to the right are louder, so theoretically closer, and the color in each graph is a different beacon. So you can see the top graph is just the signal intensities as they come in, and it's not clear from that graph whether the blue or the green beacon is closer, and it doesn't seem to follow any distribution that we know. Whereas if we take averages, many averages over a period of time, that starts to follow a normal distribution, and then it becomes quite clear that the blue one is probably closer than the green one. So that's why we take averages rather than just using raw data. But we need to have a test so that we can be sure which beacon is closest. And for this, we used the Z test, which is a statistical test. And we use the result from that by calculating the probability that we would have got that result if the beacons were the same distance away. And if we find that that's really small, we can say, okay, probably one of the beacons was closer. And then because that beacon's linked to the operating theatre, we know which room the machine was in. And the phone knows which room it's in at the moment just by scanning the QR code on the wall, so then we can make that connection automatically. If we're not sure if the probability is too big, then we can just revert to the list and ask the user to choose which machine. Yeah, so that's how we generate the list. We're gonna have a 5-minute break now while we set up the app demo, and then Alex is gonna walk you through how the list looks in the app.
So yeah, we're going to take you through the app, which is just opening up now. So the first thing that comes up is our splash screen with our logo, and then what should come up now is a background camera with an overlay of the machines. So currently it's loading and it's finding the machines around the office. But suppose we don't need a machine for this particular operation. So we've made our app such that you can just turn it off, continue with no machine, and then go on to scan, tap to scan your implant, your patient, and that data will be sent up to the cloud. Yeah, so if we do decide we need a machine, we can drag down the top sheet. We can click machine menu and it brings up our machine menu. Surprise. So if I show you what's on the screen. So, oh, by the way, if it wasn't obvious, this is the phone that I'm using in my hand and the app. And that's being shared to the screen. Sorry, I forgot to mention. So if we swipe screens, this screen here is the monitor of the anesthetic machine. So we can see what would be shown were we in the operating theatre looking at it. So we can see 63 is the pulse rate, the beats per minute. And currently we've got nobody plugged into the finger scanner, so we've got no oxygen rate, but that's okay. So we go back to the machine and we can see several pies around our office, but usually it would be a hospital. So we've got multiple operating theatres running. We can see lots of pies, but we don't know which one to connect to until we look at the vital stats. So you can see there's two machines fairly close. They're kind of fluctuating back and forth. So the list is ordered in terms of proximity. So the closest machine should come up top. Yeah, so we've got two machines 0 to 5 meters, and we've got one machine further away. We know that the pulse rate is 63, so I'm going to connect to that machine and select. And there we go, we're connected, and we can drag down, we can see the pulse rate, and we can just continuously check that we're connected to the right machine. So if that ever changes, we can go back into machine menu. But that connection is now secure. So we've now disconnected from all the other machines in the hospital, and we're reading the session ID, the heart rate, and the oxygen from the machine that we want. So that's great, secure connection. And then we can continue to scan. So Jacob will now talk you through the scanning process.
Right. So I'll start with saying what a GS1 data matrix is.
That slide appears to have disappeared.
Right, so should I talk?
Yeah, just keep going.
So GS1 data matrix stands for Global Standard 1, and it's the international standard for data matrices. So they also give standards for other codes like barcodes and QR codes. So why is a GS1 data matrix used? A GS1 data matrix is used over like other alternatives like barcodes and QR codes because they can be encoded in a much smaller surface. So it's ideal for implants with uneven surfaces or smaller packaging. So we'll start with scanning in the app. So during the operation, we'll go in the operating theater and start scanning the room code, which is a ANANA code followed by a operation theater 1 code. So when we scan it, the icon on the right lights up, showing that it has been recorded and sent up to the cloud. And if we tap on it, we could see the details or delete it if we scan the wrong code. And once that's done, we could scan the patient. And the patient has a NHS wristband, as you can see on the phone screen now. And when we scan it, all the data from the NHS wristband will be transferred onto the phone and up to the cloud. This can also be deleted just in case if they scan the wrong patient or wants to change a patient. Yep. And this is also recorded in the bottom sheet, as you can all see now. And a submit button will appear. However, we cannot currently submit because the implant is not scanned yet and the toggle is on. However, if we want to send the data without the implant, we could turn it off. However, we're going to proceed with the implant for this operation. So we start by scanning an implant with a good batch and valid date, which will then be recorded with the patient data, showing that the implant has been inserted into the patient. However, if a faulty implant from a bad batch is scanned, it will be alerted and say not to put it into the patient and not record it with the patient's information. And also, if the implant is expired, the same alert will appear and the same procedure will follow. Once that's done, the user could submit the data onto the cloud and everything's cleared. Now Nu will talk through how the cloud will look.
Yeah, sorry, wires will need to be unplugged.
You turn off the speaking as well.
Yeah, finally. Okay, so slightly less exciting, but still quite relevant is this. So this is AWS. This is the back end. These are our tables. And here you can see that records have been created. If I refresh the page, we should have a new record. Yeah, so here you can see the record that we've just created along here, including the session ID of the device. So if we copy the session ID, make sure we get the whole thing, and we go over to this table, which is where we are receiving records from the Pi. Give it a minute. There we go. You can see here that we've got the records coming in. And if we search without the white space, come on. Okay, well, there's none for that one. We can try the other one to prove it. Here we go. And you can see that there's no machine if we've chosen no machine. There we go. Oh, white space. Oh, is that at the front? Well, that's why it's not working then. Amazon poorly designed the system. There you go. There's records coming in. And if we just restrict that now to the things that we're interested in seeing, because we can't send all the data. We don't have a real live person to monitor. You can see the records coming in there. So there you go. That's the heart rate coming off the machine, the time of the record creation, and the individual records. So that's how it would all link together in reality.
But Lou, that long list of items that you selected from was everything.
Oh yeah.
From the machine, is that right?
In theory, this is everything we can connect. They don't necessarily mean a great deal to me. I'm sure they mean a lot more to an anaesthetist. And there we go. Cool. Now handing over to Alex, right? Just.
So yeah, now you've seen how the app looks and how it works. I'm going to talk you through why it looks that way and why we've chosen that sort of like user interface and navigation. So this was really based on a number of considerations. So speaking to anaesthetists at the start, we were trying to sort of understand the current order of events, and we soon realized there sort of isn't like a structured order in which all of this information is recorded. But we did find a sort of window of time where a patient is hooked up to the anaesthetic machine and the surgeon is getting scrubbed in. And because this is so quick, it's enough time to record all of this information. However, it means that staff members are likely to be wearing gloves, for example. So we had to make sure that we've reduced the amount you have to touch the screen. And if you do touch the screen, can you touch it using gloves? And so we have tried the app with gloves, double gloved, and it does work, luckily. But yeah, so we had to think about that. We also had to think about sort of the environment in which it's used. So operating theatres are fast-paced, always sort of like adapting, and so we needed an app that was flexible. And as Louise mentioned in the value proposition, it had to be something that was quick to sort of just use in and out of those different jobs that are going on. And then also it had to be really easy to use to accommodate for hospitals that aren't used to sort of using technology in their everyday activities. So it had to be something that was easy to use. So regardless of your tech ability or the digitization of your hospital, you likely want to use it if you know you are. So we're using familiar technology. People are really used to this year, sort of like scanning QR codes with their phones. And so by making something that is familiar, you're more likely to adopt that. So we took this forward when designing the app. And what you can see on the screen here is the really sort of early prototype. We made several versions, but on this one, we can see we've got sort of the session ID and then a menu. So we've got items, patient, implant location. And the idea was to click on those, which will take you to the camera to scan the code. However, we soon realized that this is not very modular. So you had to scan something for all of those items in order to check out at the end, yes. But this didn't account for surgeries that don't have an implant, or surgeries that don't require an anesthetic machine. And you had to, as you can see on the flow chart next to it, you had to scan the location first so that you could be connected to a Pi to send all of that information. However, this also meant that it was really ordered, and if your patient is in front of you or your implant's in front of you, but you can't scan them because you're not in the room yet, that's really frustrating. And we wanted to avoid, frustrating the staff members that are using this so that they're likely to want to use it. So we needed to make something that was more flexible. So that was the reason behind sort of having the camera on the screen at all times, so that it's sort of like just ready to scan, rather than clicking onto patient and implant location, and that reduces the number of clicks as well. And we've also sort of got those toggles on the screen, so you can choose whether you want an implant or a machine. So yeah, this was way too prescriptive and didn't accommodate for the flexibility that you'd have to have in a surgical theatre. But Alex will now talk through some of the other features of the app and why we've chosen them.
Yeah. So as you saw in the app demo, the first thing that came up was the machine menu. There were a few things we needed to ensure. There are our main objectives. So number one is we need to connect to the correct machine, right? Otherwise, the data will be linked to someone else and it's completely useless. The way we do that currently is using the vital stats. So we can, in theory, send any stats we want from the machine to the phone. So if heart rate and oxygen doesn't cut it, we can send more until we know for sure we have the right machine. That reduced, the risk massively of human error there. So we've connected to the correct machine, good. At the same time, we want it to be easy to select. So we don't want doctors having to put in, or the user of the app having to put in a long code to say, this is the machine I want. So we've ordered them in terms of proximity, but that's not the only information we're running off. But that should speed up the process of selecting the right machine, especially if there are only like 8 or so in the entire hospital. And finally, we've all been there when we, open an app and something pops up, we just want to get rid of it. Adverts, so on, it's quite instinctive, but that would be absolutely detrimental, right? Because then suddenly your patient scans are not being linked to the machine and so on. So there's actually no way you can get past the menu without either deselecting machine and clicking exit with no machine, or connecting successfully to a machine and selecting it. So that ensures that we are actually connected to a machine. Once you've connected or you've deselected, you can go on to the camera and start scanning. So these are some of our past screens. This was B0. App was created around week 4. That was about 4 weeks ago. And it was literally just a way of scanning GS1 codes and QR codes. So Jacob was working on the GS1 codes and decoding it and reading codes. It took about a week for us to get the camera to actually be full screen without stretching everything. And there was a nice scan button all the way across the screen in a lovely format. But we didn't think this looked so good. So then we added a little bit of styling, but we wanted to add some functionality. So the top sheet and bottom sheet were born. And the reason we went for this setup is in order to have the app constantly able to scan. So we've always got the camera in the background. We can close the bottom sheet, we can open the bottom sheet, it keeps scanning. It just speeds up the whole process and makes the app more likely to be accepted by people in operating theatres. Still, there was work to be done because it doesn't look great. So we've come on now to our current app, which you saw earlier. So we can toggle off the implants. We've also added the machine menu, the overlay, which you can't see there, but it was before that screen. And as you scan, the room scanned bar will kind of light up and it will say, yeah, you've got this one, you've got a patient, and then you can finally upload once you're finished. Yeah, and there's still possibly work to be done, and progressions to be made, but we think we've come a long way in 4 weeks. Yeah, so now I'm going to hand over to Louise, who's going to talk about the branding and costing.
So yeah, those of you who were at our halfway presentation will have seen that at that time we did not have a name. So that was quite difficult trying to explain everything while also not having anything to call it. So weeks 5 and 6, that was quite a big priority for us. But there were certain things that we had to avoid. So even though it is for tracking and tracing medical implants because of certain connotations at the minute, we thought we should avoid that. And also, it turns out if you try and name something that has medi at the start, it's already taken. So no. And quite a lot of the riffs on scan are already taken. So the existing schemes are scan for safety, care scan. So we wanted to kind of avoid that as well. So that's when we landed on theatre capture, which I think encompasses everything that it does quite well, capturing the theatre. Yeah. So then we wanted to try and get a logo as well. So these are 5 of the many mock-ups that we made of just trying to have something that either some are riffs on the HDI logo, so the HDI eye, and others are based on like a key part of the project. So either the QR code scanning or the heart rate and the machines, things like that. So we sent out 2 rounds of surveys to like the core interns teams, because after you've been making them, you kind of look at them all and you think, I don't know which one's actually good here. And got quite good feedback for the one that you'll have seen throughout the presentation so far and on your invite email. So this one does both. We've got riffs on the HDI, but also have the scanning. So yeah, we're happy with that. So another important thing that we had to think about after coming up with our actual project is the feasibility. And so then that was thinking about how much does it actually cost? And we realized it wasn't particularly feasible to think of it in terms of one operating theatre, because number one, the number of hospitals with a single operating theatre is pretty low. And number 2, you won't implement this in just one of them. You would get it in the whole lot. So that's what we based this off of. So the first set of highlighted things there, fairly low cost, first of all. So printing out things like this for the QR codes for the wall. And then a band 5 technician to come through, set up all of your pies in the back of your machines. We figured it'd be maybe about a day of work. And then the third one there is a cost that we have figured out that doesn't necessarily have to be there, but it's a bit of a fail-safe. So we've based this off of using your own phone, but some people might not be happy with that for whatever reason. If they want to, keep their work life and personal life separate, yep. Then we've done some searching on Tesco Mobile to see the kind of phone price that we could just have for maybe for the hospital. If we could say, okay, anybody who has an operation scheduled today where nobody wants to use their phone, here you go, use that. It's got the app loaded on already. Okay, and then the Pi itself, this was quite interesting because all the experimentation we did was with one of the newest Pis, so the 4B, which is about £70 for one. But it was only a couple of weeks ago that we realized that that was something that could be minimized as well. So the Pi Zero, so the most basic one that's available at the minute, we figured out that we could actually load everything onto it and just use that instead. And there's no difference. So that reduced the cost by a lot. And then the various accessories that we need to actually get that to work. And then last of all, this is the only recurring cost. So the AWS itself. So because that is a subscription basis where it's based on the amount of memory you're using. So the more times that this is hooked up and that the operation theatre is sent, so the more operations that are carried out, the more memory you're going to have to use. But then Tom calculated that for an operating theatre, a hospital with 8 operating theatres, where they're being used 12 hours a day, then yearly, that's £50. So not a massive amount as well.
You didn't cost for the null mode.
Okay, and now Jazz is going to chat about our USPs.
Our occupation.
Yeah.
Yeah, so this is kind of like a summary slide, I guess. And we think the solution that we've come up with holds advantages over the current system, giving us some unique selling points or USPs. So for example, okay, bit of a spoiler. So yeah, we're implementing clinically valuable data. So as we mentioned before, the stats coming from the machine are anonymized, and by connecting them and linking them to the actual patient and storing them together, we're making that data usable. We had to make sure, again, that whatever we came up with was faster than the current system of writing things down, and we feel like we have done that. So this frees up staff time to carry on doing the jobs that they want to do while still doing this important data collection efficiently. And even though it's still quick, we're still collecting enough information that allows you to recall patients if required. So we created an app which we think is quite unique. It removes the need of having to buy handheld scanners or zebra scanners, which previous scanning pilot schemes have done. And although some of these have a monitor, by developing an app, we've been able to optimize the user interface. And it means we can download that on any sort of smartphone or tablet. And as Louise just described to you, that really significantly reduces the cost of implementation. Because we're using existing technology and existing devices, and some hospitals even have their own tablets, and it means a system like this is ready to be adopted by hospitals. And as there's sort of this inevitable progression towards digitization in healthcare, we're helping to sort of bridge that gap, because we're using not really scary technology, and so yeah, it's a nice step into using technology in hospitals that perhaps don't use so much. So with this low cost, we're easing integration, and it's something that can therefore be implemented across the UK. And so this means that regardless of the hospital you're in, you're being given the same level of healthcare and patient safety, which we think is really important. So yeah, to sort of summarize again what we've just spoken about, we've also got a pitch video to show you. The current way that information is recorded in operating theatres is without doubt inefficient and hazardous. Theatre Capture is working to solve this by digitising surgical data collection. Clinical data from anaesthetic machines is noted by hand every 5 minutes during an operation. This process is time-consuming and means this valuable information is not stored within an electronic record, leaving databases incomplete. This poses serious risks when other key details are missing, for example, information about the manufacturer of a surgical implant or the exact patient who is receiving a medical device. Without this, it is impossible to reliably track people with surgical implants who may need to be recalled in cases where a batch is later flagged as faulty. To add to this, the quality of a medical device is often only checked manually after implantation, to save time in the fast-paced environment. However, the complications this may cause comes with a huge cost, as proven by the PIP breast implant incident and the pelvic mesh scandal. When evidence was brought forward highlighting the potential dangers of these implants, there was no way to identify and contact all patients with these specific implants, leaving thousands at risk of preventable damage. As well as causing a great deal of stress for patients, the reputational damage creates huge distrust towards our healthcare system, proving the urgent need for a national solution to record surgical information in a safer and more efficient way. Here at Theatre Capture, we've come up with a product that is reliable and easy to record surgical information. So we're using 2 streams of data collection. Firstly, the anaesthetic machine will directly send information to the cloud. And this means that we're collecting clinically valuable data that can be linked to the patient.
We've also developed a smartphone app, which is used to input the patient-specific information. So it'll scan your patient's wristband, which has a code on it that encodes their NHS number and their date of birth, and it will also be used to scan the medical device itself. So there'll be that record of which patient has received which implant, and that will be sent up to the cloud along with the anaesthetic data so that it can all be easily recalled.
So one of the big problems we've faced is recording the location data for the operation. So which operating theatre has the operation taken place in. One of the ways we're thinking of overcoming that is to start off having the user select which room they're in, and then down the line have a look at the location data we collect and see if we can use that, for example, using machine learning.
What we're doing means that it will be easier because there will just be one clear database of everything that you can look into if recalls need to happen.
So when we open the app, we're presented with a camera, and with that camera we can scan GS1 codes on the implants or either NHS wristbands which contains patient's information which can be then uploaded to the cloud.
The benefit of theatre capture over the current systems, in my opinion, it seems like current systems, they lack one component. They don't link the data of the patient automatically to the data coming out of the anaesthetic machine, whereas our product, theatre capture, will do both.
There's often quite a big cost with implementing a system like this, using often quite expensive technologies, whereas our solution, we've kept in mind the cost, and so we're using Raspberry Pis, which are very cheap computers. We're using people's phones, so the hospital doesn't have to buy expensive tablets and phones.
Previous pilot schemes that have used scanning technology to record data have cost about £5,000 per operating theatre. A Raspberry Pi 4B kit currently retails for around £79, and as our scanning app can be used by staff phones, we've minimised the setup costs. So the upfront cost of theatre capture is just around £920 for a hospital with 8 operating theatres.
There's a large disparity in level of technology in hospitals, and our product, theatre capture, is kind of aimed at everybody.
Technology that we've used is able to be input in any hospital regardless of the level of digitisation.
By making an app that's really simple to use, we're also removing that need of training. So regardless of your tech ability, anyone could use this app to record surgical information.
It needs to be very intuitive and also quick to use during an operation.
A key benefit is the freeing up of medical professionals' time. So much of their time these days is spent inputting information that someone has written down into the correct format to be sent. But because what we do, after you scan the information on the app, it goes immediately up to the cloud. There's nothing more you have to do. So after the operation, you don't have to go back and retroactively put in information, it's all done.
The goal for me is seeing nurses and doctors, surgeons, all do what they're skilled to do. So they spend less time inputting numbers into spreadsheets, they spend less time writing on clipboards and more time with the patients, which is ultimately the main focus.
Our project is a really good baseline to record information in surgical theatres. However, it could also diverge into other aspects of healthcare and record lots of other forms of information. So for example, stock checking of medical implants could be implemented using this app. Currently, our project will notify healthcare staff if a product is expired, and so this is a really useful method to ensure patient safety. However, in the future, we think our product could be developed when a national data set is available that notifies people when a medical implant is potentially dangerous. For example, it might be from a bad batch, or perhaps people are showing symptoms with a particular implant. At Theatre Capture, we are confident that our solution will increase the efficiency and safety with which surgical information is recorded. If you're interested in finding out more, get in touch with us at 01223 603040.
Do I get the mic back on? Okay, yeah. So that does call the reception to the building here, so that'll be ringing off the hook, I assume. But yeah, 2 corrections there, as we seem to have loaded an earlier version of the pitch video onto this laptop, but the eagle-eyed among you may have noticed that the app screens that was one of the older versions we have, so it looks better now, I think, that you'll have seen during the demo. And also because we figured out we could use the Pi Zero this week. It was the newest version that has the costing to half of that again. So yeah, a surprise bargain. And I think that is everything that we have planned for except for future progressions.
Yeah, so I'm just going to briefly talk quickly about what we could do in the future with this project. We'll summarize a few of these points and then we can get on to questions if you have any. So we think we could expand the app, not just to be used in operating theatres, but also potentially for stock taking. So we could have a warehouse mode where people would just go around scanning and then they know what they've got in their hospital. Excuse me, or a configuration mode. So the person who's setting up all the machines can just do it easily on the app. And the idea would be to have a screen at the start where you choose which mode you want. And then you could, if you're always in operating theatres, you could set a default so you don't have to choose every time. So yeah, that's kind of new ways we could use the app we've already got. We'd like to do some testing of, so get actual users to test it so we know that it's working how they would want it to work. And it's not too difficult. And maybe there's other features that we haven't thought of that they might be able to suggest. You saw bad batch flagging in the demo. So we've got that code there, but at the moment, there's no database that actually contains that information about the implants. So we've got the code to do it, but then when the database is there, we need to get all the data from there. Yeah, security, we might want to log into the app. So that we can't have anyone just using the app and reading stuff from operating systems and so on. So that's something we need to think about. And then I've talked about indoor positioning already. Yeah. So we've got the machine can know where it is, but maybe the phone can know where it is. That's more difficult because the phone's moving around, but we thought we could maybe train a machine learning algorithm to recognize rooms from the beacons that are around, and then the phone can just take a small snapshot of what it hears and know the room, theoretically, and it's something we might try. Yeah, so that's everything. Thanks for listening. You're welcome to ask questions.
So yeah, open for questions. Probably the best thing for online is if people could use a raised hand, I think, which is under one of the menus. It's under reactions for me, but it might be something different for you online, but also in the room.
Well, shall I start?
Yeah.
Yeah. And it's brilliant. I mean, and I think, the other thing worth saying is that people don't realise that this is a team that never came together before. This is a group of individuals who've appeared, with a range of skills in 8 weeks, have achieved all of this in different dimensions, working together. All of the norming, storming, forming of a team has gone on to produce this output. So, I mean, just what has been presented has been truly useful. I suppose, to me, I mean, it's taken HDI to a new level, and we'll talk afterwards perhaps about what the internship does, what this sort of project does, what the relationship with other parts of the university does for us. But as we stand back and we say, well, what's generic here? You've given us a lot of ideas around. We've got an app, we can scan things. It seems to me that the fundamental problem we've addressed here is data coming out of the back of a machine, knowing that, being certain or trying to identify with certainty what that machine is and linking it to the patient. And then we can do something else with it. If I look at those components, the thing that is fundamental that you spent a lot of time working on is, how do I know I've got the right machine? Yeah, and that's the hard problem. Because you want to keep the human out of it, and we had this discussion on the barcodes falling off, the Raspberry Pi. All of these things are very real. That's what happens. I just wonder whether there isn't an opportunity to do one more thing, because you've got the technology, which is point the camera that you're at the screen there and do the AI to tell me that that machine is reading that monitor.
Yeah, well, when we were trying to get data out of the machine, we jokingly thought, well, if we can't get any data out, we can use, we can watch the screen and read the numbers.
But what's in fact, you're not looking at very sophisticated AI, because what you're actually asking is trivial things like, do the numbers change?
Yeah.
What you're trying to map now at heart rate probably the granularity, you haven't got a heart rate that is 0 to 400 and you've got 4, you've got actually a heart rate that's a very narrow range. And I'm still having to make a clinical decision with a judgment. But the ability to point at the machine and know that I've got a pi on that machine then gives me something that is generic I can use throughout the hospital. Or I've got a machine, that's the one I've got, that's the data I've got, that's the patient. I've got something extraordinary.
And actually very easily builds on top of, well, would need to build on top of the kind of distance and readings we're already doing. It's just that last
step. And the distance is probably trivial because actually I'm not worried about a machine that's 10 meters away from me. I'm standing in front of it.
Yeah.
The signal will be strongest. And again, the machine may be the place that you work out where the room is. Because the machine's sitting there all the time. Yeah, it can do the calculation. It can spend its lifetime working about which room I'm in. Yeah. Anyway, enough from me.
Yeah, we've got a question back. Question from Chris Thompson, Bristol.
Chris, can we see you? You're invisible.
Hi, hello. Yeah, possibly.
There
Hello,
he is.
can you see me? Hello. So I'm actually naughtily sitting in a clinic, just gently listening to your presentation whilst doing other things. I'm absolutely blown away by that presentation. I wish I could be there to sort of see it in person, but as someone who sits on various meetings with the College of Anaesthetists, the PRSB, sometimes NHSX, I genuinely can't believe the level of insight that you guys have got into this problem and how far you've taken it. I can't really express how genuinely surprised and pleased how well you've grasped the problem, how much you've achieved. It's incredible. You guys, I mean, you should be so proud of what you've done there. So as a medical person who sits listening to sort of, GE and people trying to punt their software solutions on us, what you've done is incredible. So well done, really good work. In terms of adding much to sort of the actual sort of process, it's slightly difficult sitting on a screen trying to get a feel for it. I mean, it looks like you've made some really good choices. I know you've just been talking about identifying the machine. We've got a relatively expensive GE pilot that they're trying to run on in our hospital, and the reason it's fallen down pretty flat is because the machine had to be hardwired into an IP4 socket. And what we didn't realize is quite how much the anesthetic machines move around. We assume they went into a room and they stayed there, but they don't. They not only go out of the room to get the room clean, they also shuffle around rooms constantly. And so the real problem GE have had is they've struggled to tell you which stream of data belongs to which room. So they can tell you which machine it is. We don't really care which machine it is. We want to know which operating theatre it is. So that pinning it down to that physical location has been a real challenge. So I think your option of pointing at the screen and saying, hello, yes, that's me, that's a real innovation. So yeah, I'd love to, if I don't know what the future plans, I don't know what Gem's got in store for this, but if you were,
why don't we give you a ticket to come from Bristol to Cambridge?
Yeah, well, I think it's got such merit, and it's the kind of thing you want to sit and look at and get your hands on and really sort of get a feel for how it works in a clinical environment. But that's so much later. But I just wanted to say to you, just well done. Just incredible on the technical level and on the grasp of the problem level as well. Really good work.
And thank you, Chris, because Chris is the guy that provided the machine that sat across the room here as well. A little bit of trouble getting it here, first of all, but only because of couriers.
I don't want to make you disheartened, but that machine, I mean, you're aware of this. The reason you've got that is because they've moved on a generation. I do hope the data streaming is very similar in the current generation. I don't know why it wouldn't be necessarily, but obviously that's something, the next step to find out perhaps.
Have to buy another magic lead.
Yeah, apparently the person who's written C# code for this machine is very enthusiastic and has written code for all types of anaesthetic machines. I don't know what. Yeah.
So yeah, that's a known thing. Ollie, you wanted to jump in.
Yeah, just to echo both Gem and Chris's points there. I mean, I was here for the halfway presentation and my mind was blown then, and it's equally blown again. So, amazing stuff. And I think my question's just been answered. So my sort of day job is trying to get data out of pathology machines from the 80s and make it usable. So my question was, how many different anaesthetic machines are there, what data is coming out of them, how readable is it, and does the anaesthetic machine tell you what machine it is, and what make it is, what model it is, and therefore what type of data it's going to have. But I think that might have just been answered if there's the very keen person who's written all the CPR code.
Yeah, I mean that we definitely need to expand it to other machines and working out what they are. But essentially, the other half of the operation, the app would not really need to change at all, and the part is just that one communication stream that is the issue.
Yeah, agreed.
In fact, apart from the null modem cable, getting the machine data was probably the easiest part of the whole thing in the end, wasn't it?
During the day that the cable arrived, it took what?
Oh yeah, we just plugged it in. Same line.
And just one more point or question, if I may, and this is way outside my expertise, but just interested in kind of the push to, well, not the push, but the recommendation that people can use their own phones. Is that a wise thing to push? I mean, are staff, do they generally have their phones on them, or do they get put in lockers? Security things, there's the app store data that shouldn't be on someone else's phone, that all of those questions sort of just immediately jumped out at me. Should there just be dedicated devices that have logins so exactly who's used it, etc., etc.?
On the app side, it literally only stores that session ID, and that's it.
Okay.
So there's
I think there's a question here for Ari, and Chris, I know, wants to come back as well.
I'll come to that in a second. I was just going to say anyway that first of all, just to echo everything you said, I mean, it's really amazing because you've done an enormous amount. My amazement is only slightly tinged by a little bit of sort of, I wish I could have been there and done it myself, actually. It's just like envy, I think. But I mean, really, and actually, I think it's not just the techie bits of the bit I really sort of love and would, like to get involved with. But I am really impressed that you thought about the whole engineering design process, because it is really important. We have to make these things foolproof, and in the NHS particularly, we train some of our fools very, very carefully and very well, very high degree. And the point about using phones, just one of my jobs at the moment just is to bring in a secure messaging service which uses people's phones, and actually there is that whole point about people do say, well, in that case you're going to buy me a phone. Well, okay, we will if you really have to, but actually how do you engage people when people start to use the user interface and find, this is really easy. It doesn't track me on my phone. It doesn't do anything bad to my phone. And actually, it's easier than carrying another phone around with me as well. People do get to engage. So actually, it's that whole piece about, does it work? Is it easy to use? And is it easy for me to use it? That's absolutely critical. I suppose I was going to make I've got lots of questions about the sort of tech, but I won't bore you with them. But I was going to make a bigger point, which is there are sort of, NHSX has a sort of skunk works for AI, and AI, it's obviously, ticket item at the moment, what its promises, I think we'll see. But actually, there are loads of things that go on in hospitals like this that are incredibly human intensive, but actually relatively simple tech, very cheap tech, I mean, trivially cheap tech, can address. And there are solutions out there that are off the shelf, like Amazon Web Services and so on, and various APIs that you could use. And I actually wonder whether or not there is a scope nationally for a more sort of a broader skunk works for tech generally, be that compute or actual hardware, or the interface between the two. Because you really demonstrated that actually with relatively little bits and pieces and a null modem, you can actually do an enormous amount and automate an enormous amount of different things. There's no one in no NHS or clinical staff would think to do that, because why would that? That's not a criticism of them. But it is possible. So who would do that? And it's not, you've beaten GE, that small vaccine manufacturer. So who is it that's going to, if GE aren't going to do that, who is going to do that in an agile way?
Chris, well, did you want to come in on the phone question?
Yeah, I was just going to tell you how things are at the moment. So we use a real mixture of our own phones and iPads now and PCs. So I think I wouldn't be put off by people using their own phones. So we run a whole clinical observation system which we just access through our phones, and it does work very well. The only And sorry, the iPads that are now in theatre do the WHO check and various of the forms that upload. So we're getting an increasing number of handheld devices available per theatre. So I think because it's an app and it's iOS, you could have the option of running it on the one provided by the trust or your own one. The only thought I was having when I was listening to it was, it's not uncommon for anaesthetists to change over, either because it's a long case or because you get called to do something specialist somewhere else. I did catch in the presentation, I think it was possible to flip the user, but that's the only downside I could see with it being on your own phone. So if it was on my phone here and I suddenly got called into the theatre next door to sort out an emergency, and I took it with me, what would happen and how would we manage that? Plus the fact I'm usually playing music on my Bluetooth speaker with it at the same time. Well, but, yeah.
I don't think the Bluetooth speaker will be an issue, but we haven't tested that. I mean, yeah, the minute you scan something, it goes into the database and it's all linked with that session ID, which is also coming from the Pi. So if you leave, anyone else can just connect to the Pi and then retrieve that record from the cloud and continue. And ideally,
once I start the data transfer using my phone, if I walk away, it doesn't matter. The Pi is still streaming up to that same session ID.
Before you realise that the code's been scanned, it's gone up, basically. Well, I mean, it's not that quick, but...
So not only is it available to you if you walk out the theatre, so you can still be managing the patient that you're not with, but should you wish to bounce it to someone else, they can come up and pick up the entire operation.
Yeah, fine.
And also, once you've scanned the three things, the phone you can put it in the bin. It's done. It doesn't. It's not a continuous process. It doesn't have to be going for the whole operation.
It's not going through the phone. No, that's just a point of ID for us. Yeah. Okay. Yeah. Got it. Brilliant.
Max.
I'm Max Prangnell. I'm a good friend of Jem's. But apart from that, my day job, I'm the director of comms for the Academy of Medical Royal Colleges, which is the umbrella organisation for all the medical royal colleges. And I spend most of my days saying no to poncy, pompous doctors who've got ideas. So an observation. First of all, I thought it was stunning, brilliant, gobsmacking, amazing. I can't think of any more epithets really. Well done. I mean, extraordinary. I love the branding. I love the marketing. To have people of your intellectual ability get down in the weeds on what colour you should use and the logos. I mean, just thank you. Well done. And you did pick the right logo. So so this is just a thing for all the doctors in the room. I apologise now. One of the huge issues that we have in health care at the moment is there just aren't enough doctors and nurses. There just aren't, and there ain't going to be. And by this time next year, I think we're going to have 12 million people waiting for an operation of some sort. How we solve that problem, I don't know. It's going to be very, very painful. It occurred to me that, and there has been a lot of talk in recent years around going to an American model of anaesthesiology, where you don't necessarily have to have an anaesthetist in theatre all the time. You can have one very senior anaesthetist monitoring lots of different rooms. Have you had this conversation?
Well, no, we actually mentioned this the other day.
So this is my question. So in the US, you'll have a suite of ORs, as they're known there, and you'll have an anesthesiology technician, I think is the word, I can't pronounce it in English, who will be doing the kind of just the turning of the knobs and monitoring. And you'll have a system of alarms, and then you'll have a series of senior consultants who will be monitoring those things. Did you have, obviously you've answered the question, but
well, we actually joked. We didn't know this was a thing.
This is how you should.
This is joked that because we've got all the data coming in, you can just have one person sat there, and then I think the punchline was that they could jump on a fireman's pole and shoot down.
Okay, so that's what happens in the US. That's absolutely what happens in the US. But you could do this. I mean, theoretically, you could be global. You could be monitoring operations procedures everywhere. There's no reason why you couldn't be doing that. We already have the technology to do surgery remotely using robots. The US used to have a robotic surgical machine on an aircraft carrier, and it can be controlled from Delaware or wherever. So I think that's the way to go. Don't be too worried about the cost. I was amazed that you were sort of penny pinching. 500 quid is frankly the cost of half a day of an anaesthetist's time. Yeah. So don't worry about it. I mean, stick another couple of noughts on that and they'll go, bite your hand off for it. So well done. I mean, just incredible. And I will talk to Jen, but I need to get you in front of the Royal College of Anaesthetists quite soon, because they'll be frightened, annoyed that they haven't thought of it themselves, and desperate for you to come and work for them. Just saying. But well done.
Thanks, Max. Chris, you wanted to come back again?
It's probably going to moan at me about.
I can't resist responding to that. You know, I don't want to burst anyone's bubble, but the American model exists in this country in varying degrees. So in the hospital I work at, we already have what they call PAAs, so science graduates who train to do anaesthesia, and then we also have this whole tranche of doctors which are called registrars and SHOs and trainees, who are essentially exactly that. And that is the system that currently exists. We have 36 theatres. We don't have the consultants to run all of those all the time. So we are supervising more than one theatre all the time. The only slight problem with the model, which I think is where it will fall down if this is the route you go down, is almost as expensive to train the SHOs, registrars and the PAAs as it is to train the anaesthetists. And the big problem is there's a lot of stuff they can't do. Now, it's fine if you're a treatment centre and you're just bashing out ASA 1 or 2 knees, hips, a repeatable production line type process, but in a tertiary referral teaching hospital, the medical complexity is so hard that it's a kind of false economy. You end up paying for the trainees and the consultants. But anyway, I just want to say that is sort of the picture it is at the moment. And we have
your phone number?
We have someone who walks the floor as it is. We're nominated to cover more than one theatre, and then we have an overall person who can run if needed. And so that's the way things are going at the moment. So a system that would allow me to check on my juniors remotely would be amazing. I mean, it should have been there 20 years ago. These machines have streamed this data for 20 years. But you know, I have to rely on someone phoning me. You know,
it's probably a bit of a stretch. There is a scary port on the back of the machine, which has a large exclamation mark next to it, which is complete control, and you can essentially do whatever you want to do in the machine. I think from that port, if you read enough manuals, so you could, you know, control the monitor remotely. In theory,
like the administration,
yeah, you sit there with your bank of monitors, you're watching, you know, 5 different operations, and
but actually combining lots of different kinds of information. The thing you've done here really nicely is you combine 2 different sorts of information and authenticate it against the same patient. Okay? And so, you know, to some extent, you know, blood pressure is a blood pressure, you know, across the patient, but actually being able to monitor and know where, at what stage is an operation, what is going on in a particular operation, it's actually sometimes more valuable when you're trying to prioritize and schedule different theatres working at different times. And actually, this one's going to be near landing soon, and so if maybe I want to just not do the takeoff there, just, you know, you see what I mean? And actually, this kind of technology, I think, you know, could potentially enable other sorts of data to be streamed as well, and then be fed to like GEM and have a usefulness as registries and facilities. So, you know, other things that one can do with it. It's very nice.
In theory, once we've got the data, it's like the positioning stuff. We haven't done it yet, but kind of the idea behind that is be listening for the beacons all the time. And once we've got the data, you then have you can just play with it until you work out how to do it. You know,
yeah,
it's just about getting it in the database. That's the difference.
It doesn't need to be implemented in real time, so you can store all the data in the cloud, and it can be kind of like, you know, listening to beacons, but not actually using the information until we have enough data to use, and then suddenly it's like bang, we know exactly where we are.
Shadow mode.
Yeah, we decided not to use the secret data, collect secret data and store it somewhere.
David.
Just to say, add my congratulations to everybody for yet another fantastic project. I think in the years these have been running, there hasn't been a dud one, and this is yet another another excellent conclusion. I think, irrespective of this particular topic and the subject matter, I am always impressed by the fact that the team works just as brilliantly as it does. The leadership, the team working, the selection of the participants always seem to absolutely be spot on. And the learning simply about the process that is adopted must be of enormous value in itself. Don't have the competence hardly at all to comment on the subject matter, but the process itself, I think, is deserving of enormous congratulations. And if there is a way to capture that, because for everybody involved, if you can take that learning and use it into the future, then you will make your own lives a lot easier than they otherwise would be. I shall leave it to others to continue to comment on the content. I'm hoping, because my daughter-in-law is an anaesthetist on the way to becoming a consultant, I'd love to be able to show her the video or send to her the video part of it. And if she's interested in that, maybe the whole of the recording, possibly without my earlier comments.
Don't worry, David, we'll cut you out.
Thank you very much, but well done to all. Thank you.
Thanks, David. Richard, you're up next.
Is that me?
Yeah.
All right. Okay. I didn't know whether the other Richard was back again.
Oh, sorry. Yeah, sorry, he is. Yes. Richard J, you're up next.
Thank you very much. Just to reinforce the comments about the excellence of the presentation, the enthusiasm, the insight. Fantastic, absolutely fantastic. Lots of the points I was interested in have already been covered. Authentication and security, I think are always there in the background. But the question I wanted to ask was, so from something that if you watch the video, you might believe had actually been dry run in a hospital. And to Chrissy's comments about, what would you do in order to turn what you've got now into something that you legitimately could put into the marketplace as an offer. So what are the steps that take us from today to something you put in legitimately into the market? Or if that's too hard a question, what is the most important next one or two things that convert what you've got into something you would be confident about standing in front of an organization and saying, are you prepared to try this in real time?
I think, there's a number of things app-wise, just making sure, it's production ready, clean, tidy, remove all the console logs, get that on an app store so it can actually be used. We'd want to rewrite, I think, the code that we're using currently to talk to the machine, just because we know what it's doing and we know what it's saying, but we're not entirely in control of what we're getting out, right? We just run the one command. We're not getting all the data we'd want to be getting out. We're not getting the alarm stuff, So that would have to happen. But then I think, at the point we're at now, I'd be comfortable, saying it's not far away from that,
But that's a technology answer.
Oh yeah, sorry.
Well, yeah, I think a lot of it is like they just mentioned in the future progressions bit about user testing, because again, like we have been going with, this obviously we have all decided that this would work, but it's so different whenever you actually try implementing it in real life. So I think that would definitely need to be done, and getting a feel from it from more people who actually are in operating theatres day in, day out. And I think that also helps with the using phones as well, because if it all just depends on the scale of things. That if there are a majority of hospitals that are happy enough to just use their own phones, then we can run with that. But if it ends up being more that there are people who are too nervy about it, then we would need to take that into consideration too. So there's a lot of market research to be done, I think. But
I mean, I agree. I agree. I think there is a technology bit, but I actually think there's a real user testing bit, and I think part of that is using that to refine the value proposition with the people that you're testing it with. Yeah. Because you started with some really clear value propositions, and I think as you actually start trying to use these things, those some of them fall away, and some of them one or two pop up that you never thought of, and so I think refining the value proposition, because I don't want to pour cold water, but there was a little conversation earlier about it's just great to join up data and have it in a big pile in the well, that in my world, I don't think that would sell it in my organisation. So I think you need to just go back to that slide where you were saving time and cutting out human error in transcription, or you were exploiting value in the machine that people sort of knew was in the machine, but actually have never bothered to plug the thing in and use it. So I think it's just that stuff that just
liberating data is important, but if you did it in the research space and it was fully de-identified, pseudonymized, then you've got a different value. It's actually data out of a machine that can be used. Once you start to get into the clinical space, you've got all sorts of problems.
Yeah, good point. Thank you.
Thanks, Richard. Richard A.
Just wanted to echo how much I enjoyed it. Absolutely brilliant presentation, and particularly to say thank you to everybody. You've clearly been drilled in terms of don't mention an acronym without explaining it. So whoever told you to do that, they were absolutely right. And also thank you for the simplified slides of the technology. I could follow them, which was great. And again, that's really important for those of us who perhaps are of a different generation and can stay with Bluetooth and Wi-Fi, but much beyond that, we struggle. But congratulate you for simplifying what's obviously very complicated into something that was very digestible. As someone who used to have to sign off on the purchase of a lot of these things, it really builds very much on what colleague Richard said. I wonder who would champion it for you in each hospital, because it's the sort of sum of money that's not going to get discussed by the great and the good with all the pros and cons. It will actually go through a hospital process on the basis of one reasonably influential person championing it, saying, this is what I want, I need £5,000 to get it in, I need IT's cooperation. And so it is a question of working out who your champion would be. And as Richard said, the value proposition. I had a couple of thoughts. One was safety is always a really good seller. If a clinician stands in front of a board and says, give me £5,000, it'll improve safety, the discussion is very short and it goes through. And you had got a safety angle in terms of never put an implant into a patient that's expired, that's got a warning on it or something like that. That's the sort of thing that simple people like me who make these decisions understand. There's a lot of other benefits that might get your clinicians and your analysts excited, but in terms of actually getting it in, the safety one will always win. So you can go through that route. And also, I suppose, the academics might also make a case for the data in that it's cheap enough, and you might be able to go through your AHPs and all the people who sit on the side of teaching hospitals to say, look, just give us the money. We want to run a research program to get this into every theatre in teaching hospitals to get the data out. They might do it as well. And obviously, Chris was speaking about anaesthetists and so on, making a case for it as well. But do think about your champion. I thought your script on your video was fantastic. But as Richard said, what it really needs to be is it needs to be with people in white coats saying the same things that you said. And rather than saying it will, you need the people in white coats saying, I really love the way that it does this. I love the way that I pointed at a machine and it's done. I love the way that I can do it in lots of different orders. I love the way that it doesn't tie me down. That sells in a way that, unfortunately, people like me that don't wear white coats just get ignored. So much as the script is brilliant, it needs to be people in white coats talking about it. But no, I absolutely loved it all. My last thought from commercialization was, had you thought about going to people who provide implants and wondering whether they would provide this free alongside their implant contract, because it's cheap enough that it might just give them an edge to say, actually, if you use our implants, we're prepared to put these into the theatres because we like all the tracking side of it as well. It would obviously have to cover every manufacturer's implants and so on, but you might actually persuade one implant provider to actually say, I love this so much, and the safety angle for being able to trace every patient that's got my implant in is so attractive that actually I'll pay alongside the implant contract to put it in.
Yeah. I had never thought about how useful this would be for implant manufacturers. It never crossed my mind. But why would they not want it, you know?
Yeah, just sorry, just a point. Why? Because I was going to say the same thing. I'm used to working in an engineering environment where we have to, on a motorcycle engine or a car engine, we have to track every torque setting, every nut and bolt of every unit we produce, in the event there's a technical problem that puts anybody's health or life at risk later in use. I'm surprised that that's not a standard in the medical appliances industry. And I think that's a really interesting pathway to pursue. In most of my world, it's mandated legally that we have to do that. So I would think that might be quite a useful process to pursue.
Yeah, well, that's what Cumberledge report has done, and the government's undertaking on it, is to say you've got to be able to do this. But scan for safety is £2 million a site.
Yeah, but it sounds like a fairly another reason why people should be taking it seriously. So anyway, I was going to butt in earlier, but just to say, I think the only epithet we haven't used yet is glorious. So I'll add that to the lexicon and just say that. I too share exactly what everybody has said. I think this is I get lots of uplifting days working with HDI, but annually this day is always the best. So this has lived up to the previous standard, and well done, guys. In particular, one of the features I liked, which was mentioned earlier, is you've worked on both the practical and the theoretical, and I think many of the challenges facing HDI actually center on that. The quality of the intellectual thought process within HDI has always been absolutely fantastic. I think many of our problems getting traction come down to really understanding what goes on the shop floor, what goes on in the hospitals, what's going on with the people that are actually dealing with the problems we're trying to solve. So I found that whole sort of practical aspect of what you've been doing in the project really interesting, really helpful. So thank you for that.
Thanks, Sean. So Chris has had his hand up for a bit, and then Lisa.
Yeah, so I've made lots of comments, but you certainly jogged my memory about the research aspects. We have mentioned it very briefly, but that's not to be underestimated. So we spend a lot of time filling in forms for so the National Joint Registry, breast implants, vascular, the NELA database. There's probably, I've made a list for a project with the college, but there's about 15 databases that we have to fill in per operation, most of which require the highest and lowest blood pressure, the heart rate, the BMI, all data that's being streamed. So in terms of a cell on a clinical level, if you gave me a system that would automatically send that data and fill that form in for me, especially the NELA database, I would bite your hand off, because it's 20 minutes of my time digging through it. The second thing is a sort of quieter mission. I know it's unfashionable to kind of collect data globally, because I think the GP ones fallen off a cliff a bit at the moment, but I have a dream. And the dream is that I set the standards with the college and the PRSB for what constitutes a standard anaesthetic chart, i.e. the stuff you're collecting. And then when I send that data to the cloud, why doesn't that data end up with the college or NHSX? And then next time we have a pandemic and we want to understand how many people were taken to theatre with COVID, how many people had low sats, all of that kind of on the hoof data analysis that currently we're all involved in. So the world has changed quite a lot in the last few years, but we're trying to make sense of a picture that we're living in right now. how easy, how great would it be if that data was all popping up on someone's computer centrally, and you could do a big sort of almost real-time analysis of data to decide what's significant, what's important, what are we doing with this? So that's my job. It's a little bit further on, but the research aspect of this sort of project, I think, is very, very significant.
We don't have the diagram, but there is a diagram on one of the whiteboards with a big circle on it and the word data pipeline or something, I think, and lots of lines going off. So yeah, once we've got the data in AWS, it's no effort at all just to pipe that somewhere else, you know? Well, no effort at all.
Has its challenges.
Yeah.
Yeah, thanks, Chris. Lisa.
Oh, hi. So just to say, I think that's just incredible. So this is my first time, so I'm just completely bowled over. Jem, it's absolutely brilliant, and Kim. And the team, I mean, the word I was going to use was inspirational. So there you go. I don't think we've used that yet. Particularly in 8 weeks, that's truly astonishing. So imagine what we might do if we gave a bit more time. I think for me, I can just see so many further opportunities. We've touched on some of them, either direct care or using data for secondary uses. But given so the big sell point, and I forget who mentioned it, but you know, at the moment, everything is about clinical efficiency and clinical productivity, as we kind of have our response through elective recovery. So I probably should say I'm a chief information officer in a large hospital based down in Southampton, but I'm also the CIO for Hampshire and the Isle of Wight integrated care system. So I've come at this from sort of different angles. But all we're obsessed about at the moment is elective recovery, and I can see how this could really help because it's all about clinical efficiency and improving safety, so that's brilliant. I really like, in terms of the next steps, the thinking around stock monitoring, bad batch tracking would be fantastic. Some of the thoughts that occurred to me were about testing and regulation, so whether there's an MRHA linked to this. And certainly I work quite closely with PRSB, and I think that making that link with them as well would be really important around standards. I think in the future, where we might want to think about how we get this data into personal health records, so PHRs, so that's the stuff that individual patients have, or get it onto their NHS app, so there's another link there. I did wonder about the resilience, and New and others, you'll have a better view of this, but about the Raspberry Pi. I've got one at home, actually. We haven't done an awful lot with it. I'll send it up to you. But just thinking about, is that quite the right thing? It is incredibly cheap and very versatile. The research angle, there's definitely got to be a link to the work that, and Jem will know this as well, to NHS England, the Foundry stuff, and also NHSD. And I just think if we can just find, you know, if you could just find some pilot, an organisation prepared to work with you to do some really full user testing and just work out what the regulation requirements are around this, I think it could be brilliant. Thank you for letting me come.
Thanks a lot, Liz. Good to have you on board.
Has anybody else got any words? Has anybody thought of a word that hasn't been used? Does anybody here want to say anything?
Shilpi.
Oh, Shilpi, go for it, Shilpi.
Hello all. First of all, really congratulations. You guys have been brilliant. It's an amazing work. As a app user person, I just had one query. Do you think in future, I'm not sure if you guys have already have it in place, but before you make an upload, will you guys be considering a validation check or something that a person has by mistake not chosen a wrong PI? So like ensuring that the patient you have scanned and the PI you have chosen are very close in the same location. So will you like flag it up? Are you really sure you want to upload this data because this PI that you have chosen doesn't seem to be close to the person? And if somebody has wrongly uploaded something, is there a possibility that you can revert it back or delete the information that you just upload?
Yeah, you can. So you can delete the scans, and actually, if you change PI, because your session ID is stored in your phone, then the PI will change in the cloud. But there is not that much checking. No.
And it's one important thing is that the upload button doesn't actually send anything to the cloud. It's already been sent, so it just clears the end. But it's more of a universal, like, I'm done now, I can upload. But it's actually already there in case the phone is brought away or switched off or dies or something. But yeah, we could definitely implement more like frequent checking.
Yeah, okay, good, but really commendable. Kudos to you guys. Thank you.
Thanks, Shilpi. I'll pause again. Everybody's run out of words. Fantastic. So actually, just before we do finish, there's a few people to thank. Quite a lot of people actually to thank. So many, I had to write them all down. But starting with people who supported the interns, many of them here or couldn't make it, but Chris Thompson from Bristol, thank you for providing your insight into the project from way before the interns turned up, lending us the machine, as we've already said, and just kind of keeping in and being enthusiastic about it. And Ari, who's here, basically the same message, but thank you for giving something that's almost the opposite of what Chris said as well, which really kind of helped widen the project out and make us think about different hospitals and how different tech works. And, you know, essentially you were saying, I'm not interested in the anaesthetic record, and Chris was saying the anaesthetic record is a key, you know, so, you know, that was really kind of useful and interesting. Tim, who is on holiday somewhere, was trying to get in, but was kind of our chief guru for tech, basically brought us a word every day that nobody knew, but was a key point. It became an acronym on the slide that was explained at some point today. And knew essentially who was the sort of the second key tech guy, who's not really an intern, but is an intern, but sort of just happened to turn up and spend every day here supporting the tech side of that. So thank you to Tim and Nu. Emma Summers, who couldn't make it today, and her team from NHSD, who are on the kind of data liaison side, running the National Theatre data set and providing us input on, you know, what do we want to capture and how do we capture it, and telling us not to do any scanning because loads of people are doing scanning, and we're like, yeah, but we kind of have to do the scanning because otherwise we can't link any of this stuff together. So thanks for that, and we've had several meetings with them. Some HDI people, Sophie Joes, who provided the how do you run a project like this, how do you track it, how do you do your project management, how do you keep everybody on board. So thank you, Sophie, for that, and all the HDI and PhD staff who attended the halfway presentation as well. That was actually really useful. They probably didn't know that everything they saw was a complete mock-up and lie. Now it's the real thing, but they might have thought it didn't look much different then to now, but it is massively different. And Katie, of course, who has been spending the last 8 months, 10 months, 12 months, I don't know how long it is, 8 months, planning the project, linking all these people together, linking them up, making sure the project can run, working out how it will run safely in COVID. We're largely successful with that, apart from the odd little bit of isolation here and there. But communicating with everybody and the stakeholders and coming up with lots of good ideas and giving you guys some stuff to work with on your Wellbeing Wednesdays, and also running the daily stand-ups and the project management stuff on the Mondays, the thing. So fantastic. Couldn't have done it without you. Of course, we couldn't have done it without these guys. So thank you. I haven't got any extra words, but I was just going to say, you know, you've worked brilliantly together as a team, quite incredibly. I'd like to put some of that credit down to Katie and I for doing something at the beginning. We're not quite sure what we did, but it seemed to work. And just doing an amazing job, as you've shown, and an amazing job of presenting it. Absolutely fantastic. Beautiful presentation, fantastic video. Sorry, I'm going back to all of those words again, but no, well done. And we are super impressed, as you can hear.
Yes.
Yes. Thank you. Yes, oh, thank you.
Yeah, I mean,
keep saying it, but it's so true about how good you guys are at finding the right people. We had to do this last year online, and it worked somehow because the people you manage to find and the people you choose are so amazing, and also because you guys are good and can keep it together. So yeah, thank you so much.
Thanks. That ends the formal. Oh, John, did you want to say something?
No, I was just going to ask whether you're off to the pub now. That was just thanks again. Extraordinary day. I go away for the weekend fully uplifted, and I thank you for that. I really do. Thank you.
Thanks, John. And thanks everybody for attending. Yeah, and all your questions and comments. Really good. Yeah.
Thanks for the technology, everyone, as well.
Thank you.
Okay.
Hi, Hilary.